Summary question 7.1. We start with a question that gives us three different situations with two forces, or sometimes three forces, where we have to calculate the magnitude and direction of the resultant force. So question 1, A, we have forces at right angles to each other. This one of 3.1 newtons and this one of 2.0 newtons. This is the object here that is being acted on, and they're stated they're at right angles to each other. So the resultant of these forces is going to be in this direction, that we can clearly see just by looking at it, and we can calculate the length by using Pythagoras theorem. So this is the resultant. We can imagine this side to form a triangle here, and therefore we'd have two sides of a triangle and the hypotenuse of a triangle. We can therefore use Pythagoras theorem to say that r squared will be equal to 2 squared plus 3.1 squared. And therefore r, when you do the calculation, is equal to 3.7 newtons. And we'll go to the same decimal places as given in the question. Part B. This is the same right angle style question, although this time the other force is downwards. This force here is 6.0 newtons and this is 16.0 newtons. And we're now expecting a resultant force in this direction. And the same Pythagoras theorem will apply here. Give this resultant, r squared is equal to 16 squared plus 6 squared, and therefore r will equal 17.1 newtons. Now, for both of these we need to calculate the angle, and for the angle we're going to use the tan function. And we know that for question, let's write it, I'll fit in here. For A, and for both of them, we know that theta will be equal to tan to minus 1 times the opposite over adjacent. Now, in this case, we're looking for these angles, which means the opposite will be the 2 or the 6th, and the adjacent will be this 3.1 or the 16. So for this question, theta will equal tan to the minus 1, 2 over 3.1, which works out to 32.8 degrees. And that's 32.8 degrees with respect to the 3.1 newtons. And for this one, theta equals tan to the minus 1, 6 over 16, which works out to 20.6 degrees with respect to the 16 newtons. Part C is very similar, but this time we've got a slight difference in that we now have equal opposite forces acting on an object as well as a downward force. So we have 2.0, 1, 0 and 3.0. Now the first thing we need to do in this situation is resolve in this horizontal direction, the 3 newtons force will win out over the 2 newtons force, which means the resultant will be to the right. So let's redraw the diagram. Still have the 1 newton force going down. We have a force to the right. This is the winner, and it wins by a difference of 1. So 3 take away 2 is 1. So we have a 1.0 newton force in that direction too. Now this makes our life somewhat simpler, because these forces are now matched, which means we've formed what we call a 1-1 root 2 triangle. We can then say that the resultant will equal to root 2, which is 1.4 newtons to the decimal places we've used, and theta will be 45 degrees because it's a 1-1 root 2 isosceles triangle. Okay, that's the first section. Moving on to question 2. Calculate the magnitude and direction of the resultant force of an object which is acted on by a force of 4 newtons and a force of 10 newtons if they are part 1 in the same direction, part 2 in opposite direction, and part 3 at right angles. So we're going to have 2 forces. Force 1 will be equal to 4 newtons. It actually gives it as 4.0 newtons. We'll keep it to the right decimal places so that we know how to give our answer. And it says that force 2 is 10 newtons. So part 1, or I, is if they're acting in the same direction. So we have our mass, and it will have one force and another force, F1 and F2, and the resultant will be F1 plus F2 as they're moving in the same direction, which will work out to be, for R will be 4 plus 10, so that will be 14.0 newtons. The second part, this time we've got the mass in the middle, and we've got one force this way and one force this way. So clearly one is going to reduce the other, and therefore we're going to have a resultant. F2 in this case is bigger, so we'll have a resultant in this direction of F2 minus F1. So R will be 10 minus 4, which will be 6.0 newtons. Part 3, we've now got our mass being pulled in at right angles. So we've got F1, F2. We're going to get a resultant as we did up here in this direction with an angle theta, and we're going to calculate R as being the square root of F1 squared plus F2 squared. So it's just what I've done here is gone one step further than this and taken that square over to square root, but it's still the same Pythagoras theorem. So we're going to end up with the square root of 4 squared plus 10 squared, which is going to give us an answer of 10.8 newtons. And then theta, same as here, tan to the minus 1. We've got our opposite first, which will be theoretically here, which is F1, over our adjacent, which is F2. And when we put in the figures, we'll get tan to minus 1 of 4 over 10, which is going to give us the answer of 21.8 degrees, and that is with respect to F2, or the 10 newtons. Okay, moving on to section 3. A crane is used to raise one end of a steel girder off the ground. As shown in figure 14, let's see if we can get that in the camera. There we go, figure 14. When the cable attached to the end of the girder is at 20 degrees to the vertical, the force on the cable on the girder is 6.5 kilonewtons. Calculate the horizontal and vertical components of this force. Now, with any complicated question like this, especially one where it gives you some kind of diagram with a little picture of a crane on like we've got here, what we want to do first of all is reduce this to a much simpler form. So realistically, we're concerned only with this line here and resolving it in the vertical direction and in the horizontal direction. So we can ignore this, we can even ignore the girder down there. So we can just redraw that out as a force like this, and we know that to the vertical it forms an angle of 20 degrees and that its value is 6.5 kilonewtons. So all we need to do is calculate this force here, the component in the y direction, Fy, and this force here, which is the component in the x direction, Fx. So, firstly, Fy, we are going to need to use trigonometry to work this out. Now, we have the length of the hypotenuse, because that's this side here. We have an angle here. We want this here. Because this is next to that angle, it would make it the adjacent side. So we have adjacent and hypotenuse. And if we remember SOHCAHTOA, we're looking at K part of it. Cos equals adjacent over hypotenuse. So as long as you can remember which one we use, in this case it'll be cos, the rest you can edit in without really having to put too much consideration into it. Fy is equal to f cos theta. It'll always be that the component you want is the magnitude of the resultant times either sine or cos theta. And the only tricky part here is knowing which one to use. In this case, we wanted the adjacent side, and SOHCAHTOA, K part, cos adjacent hypotenuse, tells us that it'll be cos. If we wanted fx, which we obviously are going to, we're going to have f sine theta. And we know that because this is theoretically the same as this length here, and that will be opposite, and it'll be the SO part of SOHCAHTOA. Sine equals opposite over hypotenuse, so we'll be using sine. This, of course, is going to be 6.5. You could, at this point, type in times 10 to the minus 3. I tend to just write k at this point because it's not. The answer is just going to turn out to be in kilonewtons. It's unnecessary to actually enter it into a calculator for questions. Times cos theta, which is 20 degrees, and that will give us an answer of 6.1 kilonewtons. So you can just do 6.5 in the calculator, you'll get an answer of 6.1. Just remember to carry through the k. Okay? And the reason for that is that cos 20 degrees is only ever going to times by a value up to 1. So anything from 0 to 1 theoretically, which is never going to change the magnitude of this. Not significantly enough to interfere with the k. It can change the value to a sort of an order of 10, but it can't really do anything to get rid of the k. Worst case scenario, you might end up with 0 point something, and then you might have to carry the k out and put it out of standard form, but it's not necessary to do on a calculator, it just speeds things up. So again, we've got 6.5k, this time sine 20 degrees, and that will give you an answer of 2.2. Again, we carry through that k to kilonewtons. Okay, last question. Let me just move this paper. Question 4. A yacht is moving due north as a result of a force due to the wind of 350 newtons in the horizontal direction of 40 degrees east of due north, as shown in figure 15. Very complicated wording. Let's have a look at figure 15. So we've got a yacht moving along. So I'll read that again. A yacht is moving due north as a result of a force due to the wind of 350 newtons in a horizontal direction of 40 degrees east of due north. Very confusing wording. However, the bit that it's asking you to work out, calculate the component of the force of the wind in the direction the yacht is moving and perpendicular, is very easy. The confusing part of this question is the wording, and every time I read it, I probably say it slightly wrong, but that's just a standard example of how confusing the wording they choose is. The point being that the direction of travel part, which is indicated up here, is actually nothing to do with what we're actually asking here. And be aware not to put an arrow in your pictures or your diagrams in this direction. This is not showing a force, this is showing the direction of travel, and they've drawn it in an arrow, personally I think probably on purpose to catch people out. This is the only force that's drawn on this diagram. Okay, and it's noted as newtons. Theoretically, all this tells you is what north is. So when we redraw that out in simpler terms, well, we can say that here is our north line. Now you notice I'm not drawing this in as a fixed line, I'm drawing it in as a north line. So that is the direction of travel, but it's not a force. The force is the force from the wind, which is given to be in this direction at 350 newtons, and it's at 40 degrees to that north. Now we've got a much simpler picture and something easy to solve. Again, we're going to be looking for an fx and an fy, and if we look at it, it's exactly the same as the one we've done before, so we don't even have to go through complicated working out processes. We can just say from this same equation here that fy is equal to 350 cos 40 degrees, which is 268 newtons, and we can say that fx is 350 sine 40 degrees, which is 225 newtons. And that is the answer to all the questions on section 7.1.